गाइस, वेलकम बैक टू दी चैनल ऋतुराज एंड वायर्स। और आज हम लोग करने जा रहे हैं डे 23 ऑफ 25 डेज आईओटी सीरीज। और आज का जो टॉपिक है, आज हम लोग करने जा रहे हैं ओवर द एयर अपडेट्स। ओके, सो यस, लेट्स बिगिन द वीडियो विदाउट वेस्टिंग एनी टाइम। सो हाँ, हमारा फर्स्ट टॉपिक आज का है व्हाट इज ओटीए ओवर द एयर अपडेट्स। सेकेंड टॉपिक है वाई ओटीए इज रिक्वायर्ड इन आईओटी सिस्टम्स। थर्ड है टाइप्स ऑफ ओटीए अपडेट्स। फोर्थ है ओटीए आर्किटेक्चर इन आईओटी। फिफ्थ है ओटीए अपडेट्स प्रोसेसेस स्टेप बाय स्टेप। एंड देन फर्मवेयर वर्सेस सॉफ्टवेयर अपडेट्स को समझेंगे, ओटीए सिक्योरिटी को पढ़ेंगे, ओटीए फेलियर एंड रिकवरी मैकेनिज्म्स को हम लोग डीप कॉन्सेप्ट में जाएंगे, रियल वर्ल्ड यूज केसेस ऑफ ओटीए समझेंगे, बेसिकली एप्लीकेशंस एंड एडवांटेजेस एंड लिमिटेशंस ऑफ ओटीए को कंप्लीटली हम लोग कंप्लीट करेंगे। ओके, चलिए आगे बढ़ते हैं हम लोग फर्स्ट टॉपिक के ऊपर। Okay, so as we can see here, our first topic is what is OTA, over the air updates. So OTA means updating the firmware or the software of an IoT device wirelessly using the internet without physically connecting the device to a computer, in simple words. So OTA allows you to update device code remotely. Example, updating firmware of ESP32 placed on a rooftop, updating software of a smartwatch or a smart TV. So if you have worked on an IoT system before, or if you have worked on any embedded systems, so you know, if you have made a project with just your laptop and a microcontroller and a simple sensor. So basically what would you have done there, that on the first time when you are making that project or just connecting it between different devices, you might have used a cable. But what if you just have an laptop and a wireless system that doesn't need to have that messy cable around all over your table or the system? So that is what we mean by OTA, why it is important. Okay, OTA is something that we can work on different devices without connecting them physically. ठीक है, मे बी मेरे बहुत सारे बातों का यहाँ पे सेंस नहीं बन रहा होगा, बहुत सारे एग्जांपल्स का सेंस नहीं बन रहा, बट यू माइट गेट दैट व्हाट आई एम ट्राइंग टू कन्विंस हियर यू। ओके, कि मैं आपको कन्विंस करना चाह रहा हूँ कि why an wireless system is far better than a system that is physically connected. Okay, अब यहाँ पे कौन सा प्रोज भी है कि एक फिजिकल सिस्टम जो होता है जिसमें कि हम लोग केबल्स का यूज करते हैं, वहाँ पे रिलायबिलिटी चाहता है कि हमारा जो कनेक्शन है वो कभी भी जल्दी ब्रोक नहीं होगा। ओके, बिकॉज इट इज कनेक्टेड विथ वायर्स लाइक, बट जब हम लोग का कनेक्शन ओवर द एयर रहता है या वायरलेस रहता है, तो यहाँ पर कनेक्शन ब्रेक होने का बहुत चांसेस रहता है। ओके, सो दैट इज व्हाट वी से OTA. Okay, over the air updates. So OTA allows you to update device code remotely. Example, updating firmware of ESP32 placed on a rooftop. Okay, अब आप एक रूफटॉप समझ लीजिए, 34 फ्लोर्स का एक बिल्डिंग है और उसके रूफटॉप पे एक टावर लगा हुआ है जो कि कम्युनिकेट या सैटेलाइट टावर लगा हुआ है। ओके, सो आप बोल सकते हैं कि आप हर बार अगर आपको कुछ फॉल्ट्स आता है उस सैटेलाइट टावर में, तो क्या आप बार बार उस सैटेलाइट टावर में चढ़ के जाएंगे उसको ठीक करने के लिए? नो ना। तो आप हर चीज अपने लैपटॉप से अगर कर सकते हैं, आप अपडेट्स अपने लैपटॉप से भेज सकते हैं नए सॉफ्टवेयर या हार्डवेयर का। सो दैट इज समथिंग दैट इज रियली फिनोमिनल फॉर अ वायरलेस सिस्टम। ओके, updating software of a smart TV watch or a smart TV, that is something we do on a small level, not for an industry level. This is something we do for personal use in IoT. Okay, let's go to the second topic. Our second topic is why OTA is required in an IoT system. So IoT devices are often installed in remote location, developed in large numbers, hard or costly to access physically. OTA is required to fix bugs after deployment, add new features, improve security, reduce maintenance and cost. Without OTA, every update would require manual programming, which is impractical. Okay, so जो चीज मैं तब से आपको समझाने की कोशिश कर रहा हूँ कि OTA जो है ये पूरे सिस्टम को वायरलेस बना देता है। ओके, कि अगर OTA नहीं रहता है तो आपको हर एक बग को फिक्स करने के लिए आपको उस डिप्लॉयमेंट साइट पे जाना पड़ेगा जहां पे अपने डिवाइस को डिप्लॉय किए हैं। ओके, एंड इट रिक्वायर मैनुअल रीप्रोग्रामिंग विच इज इम्प्रैक्टिकल। ओके, आप बार बार फॉल्ट्स आ रहा है, बार बार आप ऊपर जा रहे हैं, दैट इज समथिंग दैट रिक्वायर्स अ मच मोर ह्यूमन पावर। ओके, जो कि एक ह्यूमन बैठ के अपने लैपटॉप से कर सकता है। अगर उसको हर वो काम फिजिकली जाके करना पड़ेगा तो ही वुड बी exhausted and the output would be very way more less than what we could have done with just an OTA. Okay, let's move to the third topic. Our third topic is types of OTA updates. So what types of update are there in OTA that we can pass through over the air? So firmware update. So firmware OTA updates device firmware, most common in microcontroller ESP8266 and ESP32. Software OTA updates application level software, common in smart appliances. Full OTA, entire firmware image is replaced by partial OTA. Delta OTA only change parts and updated saves bandwidth and power. Okay, so let's begin with the first part. So firmware OTA updates device firmware, most common in microcontroller ESP8266 and ESP32. So what is a firmware? Firmware, we have just covered this topic in the previous video and we have really given it all. Okay, so please, if you are watching this first time, I'm covering from basics, so you might will get all the things I'm trying to convince you here, but still I would like you to follow the series so that you have a flow, you know all the system and how they work and different components of IoT. Okay, this is just a small component of IoT that we are covering today, that is over the air updates. But if you want to know about all things about the IoT, please watch my video and I hope you will like that. Okay, that is made for someone that is just beginner and starting the IoT or the electronics, we can say the electronics field, different branches. Okay, so please have a look on that, and yeah, let's continue the topic. So software OTA updates application level software common in smart appliances. Smart appliances like एक very common example मैं आपको देता हूँ, like how updates happened in our phone, how we get updates in our phone. Like अगर आपके पास कोई भी एंड्रॉइड फोन होगा तो आपको पता होगा कि कैसे वहाँ पर अपडेट्स आता है. ओके, लाइक हर 3-4 महीने में एक नया अपडेट आता है. विंडोज सॉरी नॉट फॉर द लैपटॉप, दैट इज ऑल्सो एन OTA अपडेट्स, बट वी कैन से दैट फोन में जैसे हम लोग का अपडेट आता है, लाइक Android 11, Android 12. Okay, Android 12 is in development now, so sorry for that. Android 11, Android 10, ये सब जो अपडेट आता है, ठीक है, that is an example of a software update. Entire firmware image is replaced. Partial OTA, delta OTA के बारे में भी हम लोग बात करेंगे. Only changes part are updated, saves bandwidth and power. So we do a specific update on a specific part only, and let the rest be as it is. Okay, so that is what we call a partial OTA. Okay, making updates on a specific part of a program. Okay, let's move on to the fourth topic. Our fourth topic is OTA architecture in IoT. So basic components involved in IoT devices are ESP32, ESP8266, server, cloud stores, update files, networking, Wi-Fi, internet, and the flow. How do they work? Device check servers for updates, will respond with new firmware info, device downloads update, device install update, device restart with the new firmware. Okay, if ever you have if you have deployed an IoT system in a remote area and it gets some bugs, okay, and the owner of that system, like you are the developer of the system, and someone who buy that system from you calls you and tell you that there is a bug in your system and it is not working well, please fix it physically or manually. You have both the option. Okay, so what would you do? You would always choose, I think most of the people would choose doing that remotely from their home. Okay, so that is where OTA comes in the clutch. Okay, so OTA, what does an OTA does with your computer is that, with your system, is that device checks servers for update. So the device, we can say the sensor, the microcontroller, okay, they check for the server for the update, that is cloud, and the server responds with the new firmware info that has been passed through us. Device downloads the update, device installs the update, and device restart with the new firmware. That is how you fix a bug or you gives a new feature in your system. Okay, I hope so you all get that. Okay, that is a pretty basic thing I just explained you. So let's move on to the fifth topic. So our fifth topic is OTA update processes step by step. Okay, so device boots normally, connects to Wi-Fi, checks version number from server, compares current firmware version, downloads new firmware if available, verifies file integrity, write firmware to flash memory, restart devices, runs updated firmware. This process happens without user intervention. So this is what we call a firmware update. Okay, just please ignore that the 6 and the VS, that is a misprint. That was actually a firmware update. Okay, so device boots normally, connects to Wi-Fi, checks version number from server. So what does the device do? It boots and then connects to Wi-Fi and then asks for a new version if there are so. Okay, then compare the current firmware version with the version that has been uploaded in the cloud, and if there is a difference, if there is a new version that has been installed in the that has been passed into the cloud, it takes it from it, downloads it, verifies file integrity, then write its firmware to the flash memory, restarts the device, boots again, runs updated firmware. This process happens without user intervention. Okay, that is what we call firmware update. Hope you all get that. Let's move on to the sixth topic. So our sixth topic is firmware versus software update. So firmware, a low level code, and software is application level code. Okay, firmware controls hardware, software controls functionality. firmware stored in flash and software is stored in memory storage. As you know, we use our laptop, so that is a software, we can say that it's a software update that gets a software update, and IoT system gets a firmware update. That is the difference we are talking about here. And firmware is something that is very way more critical because it works on physical level, and software is not that works on a physical level, but still sometimes software can also get critical if it is we are working on a company's databases, and we can say a critical type of thing that make a whole website run. Okay, so OTA in IoT mainly focuses on firmware update, but still software updates, error and bugs are way more, we can say that less dangerous than IoT updates. Like if we have installed an that is a good example. We can take an example of a Tesla car that has that is an automated Tesla car. Okay, so what's happen if a bug comes inside IoT? Okay, if a bug comes inside the system of the Tesla, what would happen? Let's take the worst scenario. The Tesla would go to the speed of 100 and then crash into a tree. Okay, so that could be fatal. That can take a human life. So that is way more dangerous than what a software update can have. Okay, hope so you understand that, and let's move on to the seventh topic. So our seventh topic is OTA security consideration. So OTA is risky if not secure. Important security measures: authentication, only trusted server can updates pass on the updates; encryption, HTTP and SSL is used for the encryption; firmware integrity check and version validation is also important. If not secured, attackers can upload malicious firmware, take control of devices. Okay, you might have watched some clips, and we can say a short of type of a video that where all the autonomous car get hacked by a person and it's fly off from a roof. Okay, so I don't know if you have watched or not, but I did, and yeah, I can connect that with this. Okay, so let's move on to the eighth topic. So our eighth topic is OTA failure and recovery mechanism. So failure can occur due to power loss, network failure, corrupt firmware. Solution: dual partition, old firmware versus new firmware, rollback mechanism, update verification before switching. This ensures device does not get bricked. Okay, so we have to check that with the new update, our device does not stop working. Okay, that is the main point. We know we have to get a new feature. That is good for our IoT device to have a new feature or to do something more that has been that he cannot do before. But still, the main thing that our IoT device has to maintain is that it is still working. Okay, sometimes what's happened is that if you pass on an update that is not we can say optimated according to our IoT system, the IoT system may we can say it get disabled and does not work properly. So for that, in that cases, failure can occur due to power loss, network failure and corrupt firmware. Okay, corrupt firmware I'm talking about here. So dual partition, old firmware versus new firmware has to be separated, and the new firmware should be from the basics to the all the different parts of that should be consist all different parts of that system. Rollback mechanism, update verification before switching, and this ensures device does not get bricked or stopped. Okay, let's move on to the ninth topic. So our ninth topic is real world use cases of OTA. So smart meters, smart home devices, wearables, industrial IoT sensors, automotive system. OTA allows manufacturers to improve products even after sale. Okay, so the small scale example that I can give you is that we use wearables in our daily life. We wear smart watches, we use sensor for tracking. So that is something we can use. We can say that that is a small level scale thing that where we use OTA, wireless system of OTA, and OTA is also used in manufacturing industries for we can say that a large scale deployment of IoT devices. So that is where we can use in a large scale. Okay, let's move on to the 10th topic. Our 10th topic is advantages and limitation of OTA. So advantage of OTA are remote update, cost effective, scalable, fast bug fixing. Limitations. What are the limitation? As I said, security risk. Anybody can hack it if they get the access and require stable internet. It is not so reliable than a physical work. Memory space is required. A complex implementation is needed. For the memory space required, you know that the IoT devices does not have a very high level memory space with them, or does not have a very high level system to process data. So that is a con for the IoT system because they are small, they need a small battery, they need to consume small battery, we can say power. So for that reasons, memory space are also less, and the processing speeds are also less in IoT devices. Okay, let's move on to the most important part of the video, that is the question answer. And I want everyone, okay, we will go on to the question answer first. Sorry, second. Let's talk about this. So interview point. So that is something I've added to the last of the slide to make you summarize this whole topic what we are studying today. So OTA updates firmware wirelessly used to fix bugs and add features, require security and recovery mechanism common in ESP32 and ESP8266, critical for large scale IoT deployment. Okay, hope so you all get that. I have just made you understand all the different types of topic in breakdown level. So I've simplified all things for you. You just have to listen to me and focus so you can get the topics. And let's move on to the next part of the video, that is the most important part of the video, that is question answer. So I want everyone to keep a pen and copy with them so they can answer the question. Please stop the video when I show you the question and answer, and then after you have completed the video, then you can move on to the solution part with me, where I can discuss the solution with you, and you can cross check your errors and mistakes. So this is the question part. You can stop the video right here and carry on with the question and answer. Okay, so if you have done, let's move on to the solution part. So OTA stands for on over the air access, over the air, as we say. So let's move on to the concept part of that question. So it refers to the method of delivering data updates wirelessly using the air, radio waves, Wi-Fi, cellular, or we can say Wi-Fi and Bluetooth. There are many methods. So rather than a physical cable or the USB cable. Second question is OTA is mainly used to. So OTA is mainly used to update firmware remotely. Okay, passing the updates on the air. So while IoT devices do send sensor data, option A, the specific term OTA usually refers to the incoming flow of new code to upgrade the device, not the outgoing flow of data. So most of the time OTA is used for the outgoing flow of the data, that is being used for the updates and some, but yeah, still we use sensor data to come over to sensor data that is being transferred to the cloud. Okay, and sometimes cloud also sends their commands or requests to the devices, or we can say the sensors. Okay, let's move on to the third question, that is OTA helps avoid. So OTA helps avoid physical device access. This is the biggest selling point of OTA. Without it, a technician would have to unscrew every device and plug in a cable to update it. OTA avoids the need to physically touch the device. Okay, that is what I'm trying to convince you from the past, we can say 20 minutes, that OTA is something that can reduce manpower and automate all the things and reduce the time that is being invested in fixing a bug manually. Okay, so fourth question is OTA updates are mostly related to. So OTA updates are mainly related to firmware changes. Okay, yeah, B option, firmware changes. So hardware is physical and cannot be changed wirelessly. Sensor wiring is also physical. OTA changes the code that runs the hardware. Okay, so hardware is physical, cannot be changed wirelessly. Sensor wiring is also physical. OTA changes the code that runs the hardware. So yeah, that's the point. We cannot change the things that are being connected with wire. If a wire gets loose or if a wire gets cut due to something, but we have to do that manually. We cannot do that over the air updates with sending over the air updates. Over the air updates are basically just the updates we can give to the programming side of that hardware. Okay. We can change the working of that hardware using over the air updates. Okay, hope you all get that. Fifth question is, which is important during OTA? So security and authentication is an important part for the OTA. I guess so. Yeah, security and authentication. So security and authentication is required in an OTA for we can say that no hacker or a miscellaneous person gets the access to that devices and clouds, so he can manipulate the data or can do a massive harm to the peoples or the person or the owner. Okay, in any level. So if OTA process isn't secure, a hacker could upload a virus to the device remotely. Authentication ensures the update is coming from a trusted source like the developer and not an attacker. As I was saying that. So let's move on to the short answer question. So our first question is define OTA in IoT. So we have already learned about this in deep. So let's move on to the concept part here. So OTA, over the air, is a technology that allows us to wirelessly upgrade the software or firmware of an IoT device without needing to connect it physically to a computer. Okay, that is the basic point of OTA. It's like updating an app on a smartphone. You don't go to the Apple Google store to update Instagram. So here is an example that I have added to ensure that you get what is an OTA. So it's like an updating an app on a smartphone. Okay, basically you occasionally, or we can say that frequently update your apps. Okay, like if you take a common app, WhatsApp. Okay, you might update, or YouTube. You might update YouTube or WhatsApp whenever a new update come through. Okay, so you don't go to the Apple Google store to update Instagram. So the whole point is of the update is that you don't have to go to the shops of Instagram and WhatsApp to download the new update. It can be just taken via over the air. Okay, Play Store and Google. Okay, uh, it happens wirelessly. OTA is the same concept, but for hardware chips like ESP32. So this is not OTA, but the OTA we are talking about is something that uses this same firmware and structure to updates the IoT devices. Okay. Second question is why OTA is important for IoT devices. So we already know why it is important, as I just made you understand why manual labor is much harder than an OTA update system. Okay, so it allows for bug fixes and feature addition after the product has been sold, deployed. It saves times and money because you don't need to visit the installation site. Example, a smart meter on a distant pole. Scalability, updating 5 devices via cable is fine. Updating 5,000 devices via cable is impossible. OTA solve this. So this is a very good example they have used to explain this here. So scalability means that when we do things on a large scale. Okay, like we can update we can just make updates in our system using a cable for only 5 devices, but still it would take much more time than an OTA. Okay, still we can do that in a 5 devices, but what happens if we have 5,000 devices to updates? So that is where OTA comes in and saves us. We can just pass around 5,000 updates in 5,000 devices at once. Okay, that is what we can say a very technical part of the OTA that gives it a upper hand. Okay. The third question is, what is firmware update? So firmware is the permanent software programmed into the device's memory ROM that controls the hardware. A firmware update replaces the old code with the new code to improve performance or fix error. Software runs on an OS like Chrome or Windows. Firmware is the low-level logic that tells the hardware how to blink an LED or read a sensor. Okay, so what basically it is trying to convince is that what is a firmware. So firmware is something that is coded on on a hardware to how to make that hardware run. So when we pass a update, it's not on the hardware, it's on the firmware of that hardware. We replace the code, or we update the code with a new set of codes on the firmware, and the new set of code could have a new feature with having the old features also. Okay, so that is what we can say what is a firmware in IoT devices. The fourth question is, mention one real life example of OTA. So a Tesla car receiving an update overnight to improve its battery efficiency, or autopilot feature, or a smart watch updating its interface via Bluetooth. So there are two types of example that we have discussed here. Is that we can say that a Tesla car getting an update on this automatic driving system and the battery power consumption system, and then we can say another example was of a smartwatch updating itself for a new dashboard or an interface. Okay, over with a Bluetooth. So fifth question is write one advantage and one limitation of OTA. So we have discussed way more of advantages and cons in different parts of that in this video. So advantage, convenience, remote maintenance. You can fix bug in a device located in another country instantly. Yeah, that's a good example. If you have sold a device that is to a person from another country, or we can say a foreign person, you can still manage that product just sitting in your room from another country. Okay, so that is a big time, we can say, advantage for OTA person. So limitation is that a breaking risk, someone breaking your data or stealing your data or manipulating your system. If the power goes out or the battery dies during the update, the device might become corrupted and stop working completely, become as useless as a brick. Okay, so as I was saying, so many things can happen if we do this OTA system. That this OTA system needs way more much maintenance than a physical system, but still it can scale to a much larger number than a manual system. Okay, hope so you all like this video today. You got all your topics clear and all doubts clear. Still, if you have any query, doubts, please comment it out. I'm always active and seeking out questions to answer. And yeah, that was all. Day 23 is completed. We are just 2 videos away from completing this series, and then we would jump onto a project for this IoT system. So yeah, bye. We will meet you tomorrow for the day 24. Please follow me up and subscribe me on the channel. Bye.
And now, folks, it's time to say goodnight. We sincerely appreciate your patronage and hope we've succeeded in bringing you an enjoyable evening of entertainment. Please drive home carefully and come back again soon. Good night.